bakom det hela. Hur gör man faktiskt en sån här grej? Och då har vi ju ingen mindre än Angie här från Gapminder som ska ta oss igenom det här. Ja, from zero to Gapminder Bubble Chart in 40 minutes. Det kommer bli lite svengelska här, så ni får vara beredda på det. Hoppas det är okej.
From zero to hero.
Perfect. So, take it away.
Yes, thank you so much. Thanks everyone for coming to this little lecture. I hope it will be fun. I've been told that you want to learn some technology, some programming. So this is like looking a little bit behind the curtains of what Marcel was just showing you. Hyningeanalysen and Boendebarometern as well. I will show some examples from Boendebarometern. But yes, this is my work, this is my cat, let's go. Here is, yeah, it's working. Here is my resume, I'm not going through it, but here is some universities that you may recognize where I studied. And I teach here, and here is some companies where I worked, which you may recognize, and I work there. This is my consultancy now, making charts, you know. This is how my work looked like. I come from a controls background, automation. So these machines, they operate the factories, yeah. And then I got interested in these operator user interfaces. And I thought, oh, this is very cool, I want to study this more. And then I went to study in KTH. I studied for 2 years human-machine interaction, and I learned how to make user interfaces. And then I got excited about data visualization and presentation. Then I joined Gapminder. I spent 10 years at Gapminder as a recently head of software there. And then now I teach at the university. These are my students, and they're using these machines to create data visualizations, both by hand, but with computers, but also with robots here. And this is me teaching in one of the courses. Bit more about Gapminder. These are some of the charts that you may have seen. I have built those together with my colleagues at Gapminder. And today we are taking a look at this bubble chart. Yes, so Marcel was showing it on one half of his screen. But we have to go a little bit more technical this time. So I wanted to show you how to build this from scratch, yeah? From complete zero, and we'll try to do it in 30 minutes, and then we'll answer some questions. But maybe it will take 40 minutes, I don't know. So first we need to get the data. First we want to join the data tables together, and then we make the bubble chart. It's that easy, yeah? We set X, Y, size, and color to be the ones that we want here. And then we add the time slider so that we have some interactivity. And then we add the big gear in the background. So this is what we're going to do today. And then we embed it into the web page so that we can also show it and demonstrate it to the world. Yes, let's start. These are technologies that we're going to use today. It's called observable notebooks. If you have done R, if you have done Python, in Python we have Jupyter notebooks. So this is like a similar approach. Online coding playground. This is how I call it. It's based on the approach of reactive programming. Have you done reactive programming before? Raise your hand who's done reactive programming. I see too few hands. Have you written a formula in Microsoft Excel? Raise your hand. You have done reactive programming. You update one cell, other cell updates, yeah, the value, because it watches the other value, yeah, and then the next cell may watch the other value, and then they have this dependency graph, and Excel solves it, and then one updates the other, and it doesn't matter in which order the cell comes, yeah. So here it also doesn't matter in which order you have the cells, except in observable. You have like a little bit more space in the cells to write your stuff, and you have more lines there, and you can write JavaScript. That's the only difference. But the approach is basically Excel. And then we'll use observable plot, which is open source library. It's the approach is similar to R. If anyone's done R, this is like you create visualizations as like sentences. So I speak now. I have my verb. I have my object, subject, and so on. Yeah. In here we have geometric points, and we declare them. We make them out of cars. In observable plot, you declare it like this. Make geometric dots out of cars, and then these would be my visual encodings, and in ggplot2 they're called aesthetics. But this is basically the same approach here and there, and it's called grammar of graphics. Now we have a couple of helper functions, but don't think too much about those. So how is it working? You first make a free account at the Observable HQ. You have the slides later, so we won't create the account now, but I want to take you through the entire process from absolute zero, you don't have the account, to actually having a bubble chart that is interactive. This is the first screen, and then you press get started, and you press sign up for the notebooks. You'll have the slides, yeah? And then you punch in your email there, and then you get this confirmation email, you press sign up there. And then it goes back to Observable, and then you have to name the workspace there. So this is a bit tricky. And then you press free, yeah? You want free notebooks, you want that. So, the workspace there, it's usually your organization, so you can have something like Huddinge Kommun, or Södertälje Kommun, yeah? And then, after you press create account, it shows you this empty page where you can start creating notebooks. This says nothing here yet, of course. And then if you press here, then you can start creating notebooks, and you have them done. Yeah, that's it. That's the whole setup. Nothing to install in your computer. You don't need to mess with like something doesn't work on my Windows or Linux or Mac, but I need to solve it. But no, it's just online. Yeah. So very easy. So then instead of creating our own notebook from scratch, I provide you with the starter page. So when you press the starter page, you land here. This is how it looks like. So this is my Gapminder account, and this is my account here right now. So I cannot modify what I have at Gapminder because I'm not logged in as Gapminder. So I press fork. This means that I copy this to my own account. It's called enchant me. Yeah? Enchant me, and I press public. So, and then I press fork. Now I have the copy of the same thing. And now I can start editing. So these are the cells. So here I have something like, I can type like A equals 1, you know, and B equals 2. And then if I type something like C equals A plus B, then it would compute the sum, like the Excel is happening basically. And then if I update them, I update A. Let's see if C updates. It did, yeah? So this is like the whole thing. But you can have like advanced functions here, and you can basically start writing JavaScript. But if you don't know how to write JavaScript, then you get your favorite helping spirit, like a chart GPT, yeah? And you ask how to solve the syntax and so on. First, I'm gonna show you how to fetch a file online from the internet. So we're gonna recreate the bubble chart from Gapminder. And to create the bubble chart, you need population, life expectancy, GDP per capita, and you need country names. I start by, this is why I wrote here these links. If I open in a new tab, this is how it looks like. Look, it's a CSV file. Has anyone seen CSV file before? Yeah, it's easy. So country, time, GDP per capita. This is the CSV file. And if I take this and I use this helper function, d3.csv, I give it that file, and it comes here. I don't need those, so those I can remove. See, if I remove the dependencies, then it breaks. But of course, this is expected. Yeah, and these are my GDP per capita numbers. You can see that numbers here are quoted in like quotation marks. That means that they're not actually numbers, they're like text. So to fix that, there is a trick, D3 auto type, and now we converted them to numbers. So these are the tricks. Now we assign this to a variable, we call it GDP, and now this is our GDP data. So this is it, we have GDP. Now let's create the same thing, but we change it to, we change it to life expectancy. I just remember that it's called LEX. Oh, see, two things named the same name. That's not good. Fix the name, yeah. Now we have life expectancy. And I want also a population. So I create another cell. And now I don't forget to change population. I think it's called pop. Let's see, a shift enter is like a quick way to run the cell. And you can see how I have the code here. The code can be anything, and I have the output above the cell. So I immediately see what I'm actually doing. And now we have our GDP, life expectancy, and population data in the notebook. It's all loaded, it's all here, we can start working with it. But I also wanted to show you another way to add the data. So this is like a CSV file available somewhere on the internet, and these are actually the files that we use at Gapminder in production. But also you have this like paperclip button here, and this says file attachments. Yeah. So here if I have a file on my desktop and I drag it here, this is then here. Yeah. So that's another way. Add a file and then copy usage code, and then let me go back, create another cell here, and I paste that usage code that I copied, and I assign that to a variable countries. Yes, now I have countries, and these are country names and the regions and so on. Okay, first step done, we have loaded the data. Now all our data is in separate tables. Who's done databases before? What do we need to do? Join, yes, exactly. So to join data tables, we'll be using Arquero. It's a library that helps you do the data wrangling. So it basically does it similar to SQL, but it's all local here. So you can like select different columns, you can rename or derive different other columns, and you can join data tables. So to do that, we say AQ for Arquero.from, and then we create a table from GDP. And then if we do that, it says like 3 columns and this many rows. And then to get back to array, it says we need the objects, and we get back the array. And let's output also this as a table. So if this becomes yellow, the button below, that means that you have magic suggestions. And then if I use this magic suggestion to create a table, then I see the result of this operation. So right now I converted my GDP data into Arquero object, and then I converted it back to JavaScript array, which means that it does absolutely nothing. But now I can also dot join full. This is full outer join from like the databases, and then I need to create another Arquero table from life expectancy. Yo, look, there's like 2 columns, there's GDP and life expectancy. And now it's even easier, because now I just need to copy this and rename that to population. Now we have population. Now I do that. Data wrangling kind of becomes easier with time. Countries. Yes, and now I have all my data from countries. So the data joining can be tricky, because in the countries, you know, the data only depends on the country. But in my life expectancy, GDP, and population data depends both on country and year. So what happens is my country table here explodes. Look, it goes like Afghanistan, Afghanistan, Afghanistan. It repeats it so many times until all the years are over, yeah? And then after like I go like 200 years, or how many years I have there, then I start seeing Angola and so on. Yeah, and then it also has so many columns here from my country tables. I don't need so many columns, so I can type there here select, and here I select only the columns that I need, which is, I believe, country, name. Oops, something broke. What am I doing wrong?
It means an S in the select.
No, I think I need like this.
Okay.
Yeah, so I forgot the syntax. But syntax is easy these days, because then you just ask your helping spirits. World for region. I also need world regions to give them colors. Okay, now I have Asia, Africa, cool. This is the whole full data work that we've done now. This is data joining, and what did it took us, like 5 minutes? Yes, so now I want to create a chart. Now the exciting part actually starts. So here, when I have a data table like this, I can also use this to select and filter my data, and I can narrow it down to only like a range, see a range of life expectancy here. So this is like interactive, and then I can save the output of that table into like a new variable. But I don't need to do that. Now I press the plus button right under the table cell, and if I press it anywhere else, see, it doesn't give the magic suggestion. But if I do it immediately under the table cell, then it can say create the chart. So this is the magic suggestion because I'm near the data table. Here I create a chart, and it gives me this little form where I can say X, Y, color, and so on. This is what we need to create a bubble chart. I say X would be GDP per capita, and it already shows the histogram. This is like the distribution of all the countries in all the years. I can customize it to show a logarithmic, yeah, x-axis. And then for y, I can set a life expectancy. Now my bars are not making sense anymore, so it turned them automatically to dots. See, mark is out of dot. It's a good choice, but I can also fix it manually, like dot. And then color, I can say world for region, and I have different colors. And then size, I can say population. So this is Gapminder Bubble Chart, but it doesn't look quite like Gapminder Bubble Chart. Why? Time, yes. It shows all the years that are available in the data. But we don't need all the years, we just need 1 year. So what do we do next? Then this now becomes a bit limiting. Yeah. So if I go to customize, I have these like margins, and maybe I can set the width of the graph, and I can set height to like 600 pixels, which is nice. But I don't have any ability to, oh, sorry, a full, I pressed the wrong button. 600 here, and what did I have also? X to logarithmic. Yeah, go back there. But it doesn't have the filtering. But there is another magic suggestion on the bottom of this thing, and then if I press that, then I can convert this to JavaScript. So now the coding part we're starting, so to see how we can work with code. So by doing that, it converted the same exact thing, but this is made with a little form here, and this one is made with code. And this is how much code is needed to produce a graph in this library observable plot. So we can read it like color, legend, true. That means that it puts out the legend here, yeah, for the different regions. And then it has width and height, and it has logarithmic on X, and it takes my data, and it does X GDP capita, Y life expectancy, stroke, world for region, and so on. Yeah, so now let's customize that. We don't need this anymore, so this one we can delete. Press there, and now we just have this. So I would like to add a filter. So then if I do add a filter, then I need to provide a function. So this is a function that does nothing. This is usually my approach. I first do something that does nothing, but it has the correct syntax, or it has like the correct shape. But then if I say f dot time equals 1950, equal need to be like, it doesn't do anything. Let's see why. I have my notes here. This is the risk of live coding, because when you do live coding, it's nice when it works. somehow it worked. It worked when I know why, but it's like hard to clarify it. But I need this data object, and I got the data object out from this data table, and not the one that where I was joining the data. Anyway, it works now. Let's play with it. We can do like 1800, and we can do like 2000. Yeah, see? So then it starts looking a bit like a bubble chart. But it's too hard to change it manually all the time. So then let's add a slider. So when you create a new cell, you can search things here. So if I search slider, it suggests the range. And then I can change my range slider to have a certain name, like a year. And it starts at 1800 and it ends at 2025, let's say. So there's like some. We give it a label, year. We give it a step 1, that's good. And we give it a default value, which would be 20, maybe 23. I guess that's all we need. And then we get this. So now I can change the year. To verify that it works, you can just create a new cell and check out the year. See? Now it changes like that. So I can add interactivity elements here in the document. And I can use this. Instead of just changing it here, I can just put it directly into my code of the chart. Let's see how that run the cell. And now that works. And now I can move the cells because the order, as I said, doesn't matter. So, and then here I also can fold and unfold the code for the cells. So sometimes the code is not so interesting to look at. Then you can fold it and then you don't see it. Yeah. So now we have a time slider working for this bubble chart. Let's see. I think we have also time to customize the appearance a little bit. So that it looks like more Gapminder-ish. So instead of stroke, we'll use fill for color. See, now we have fill there. But for stroke, to add some contrast, that's what Marcel didn't do in his Houdini-analysen. But here we can add like a little stroke around bubbles so that we can see them stand out against each other. But it's easy to fix. But it's the stroke is there now, but it's a bit too heavy. So I can change my stroke width to 1 pixel, and then no 1. No 1 as yeah. I felt towards the correct syntax. Okay, stroke width is 1, and then opacity we may say 0.8, so that they're slightly transparent. It's nicer to look at. And then I also want to change the default radius of the bubbles, because now it's they are a bit too small. So if I say R, which is my radius encoding, I can give it parameters and I can give it range, which would be from 1 pixel to width divided by 17. I just remember that this was like a good value. But I can do I can do anything. Like 50 pixels is here, 10 pixels is like, oh, that's too tiny. 100 pixels is too much. If I say width, that's too large, yeah. But width by 5, yeah, too much. 15, yeah, it's a bit too much. Width divided by 20, I guess that's good. Because it's width, this is now responsive and interactive, right? So if I change the size of my screen, see, my bubbles become smaller automatically because they react on the width that is there in the notebook. Okay, and I also need like a X, let's say grid, true. So that will give us the grid. Y will also have grid equals true. And now we have grid on X and Y. And I think, oh no, the colors are not like in Gapminder. Gapminder as soon as I can type properly, I can show you the original tools. Sorry. So much stress. Here are the colors that should be appearing here. So I saved my little color values to use with my regions. So in the color I can type domain, which means that I can manually set what data values I expect in my scale. And my domain would be Americas, Europe, Africa, Asia, and unknown when it's missing. For range, this is my output of the scale. So here I have to set the colors also for this one for Americas, this one for Europe, this one for Africa, Asia, and unknown white. So the triple F is like white color. And then I made a mistake somewhere in the syntax. Do you see it? Because I don't see it yet. No, here, it's instead of like, I thought it was a cursor, but it was like this little symbol that, no, that looks like a cursor. See? So similar. Anyway, here I have my colors now, and here is my bubbles, which, yeah, pretty much look very similar. We are at 30 minutes, and we didn't start like sharp, we're at 27, and we already have a functioning bubble chart with all the mistakes that I'm making on the way. But what else? What else are we going to do here? Yeah, I can show you how the colors, like because it's an interactive notebook, I can create a new cell, I can type color here, and now I have like a color picker, and then if I use that color for my, let's say, Asia color instead of this one, like it's an interactive playground, see? So I can also change that pretty smoothly. The people who made this observable notebooks, they are like super good professionals from data visualizations. They make the best tools ever, and it's all free and open source, and it has something like it's free for if you want to use it as single player. But if you want to invite your colleagues from commune, then it's like $20 per person per month. So that's for rich companies who have $20 per person per month. Yeah, and now let's add a final change here. I wanted to add the year in the background. So in our understanding of grammar of graphics, this is what I teach at the university. I teach data visualization. Surprise. Here, our dots here, it's one type of mark, yeah? It's like our characters in the theater. And then we attach different aesthetics to them. We change their size and colors and position and so on. But now we need another mark, and that would be a text mark. So if we type inside the marks here, so this is marks, we start typing plot.text, and this will be our text mark, which I put it before the dot so that it ends up being behind the bubbles, you know. And then in the data, I just pass an array with only year. This will be one single value, because we need one single array, one single element on the screen that shows us the year. And now we need to give it some visual encodings, which would be text is the most important one. I think it's like this, but I can also just convert it to a piece of text in case if it was a number. And then I also need to give it positions on X and Y, which let's say X 3000, because it's in the units of font size as well. The X and Y is in the units of data. And font size I can do like 50. Yeah, do I have it now? Yeah, pretty much. So now I just need to style it and position it correctly. So in X and Y, I was like struggling with this a little bit, and then I found like a ninja move how to position this element so that it ends up in the center of the display. So for X, I take the maximum value of GDP per capita. D3.max, this is how I take maximum value of data, and I access the column GDP. Pcap, this is the column. And then the center of my text ends up in the maximum value there. And then I do the same for Y. For Y is life expectancy. So it's there in the corner. And now, because I have my width and height, I can move it half the width and height on the screen. So then I have these little helpers dx and dy, and though for dx I set minus width half, and for y here I don't remember, maybe height by half. Height is 600 here. Yeah. And it's not nice to repeat the same constant value, so let's just create a little variable for that. Height 600. And then we can use height here like that, and height here like that. And then it's in the center. See, that was the ninja move. That places it in the center. And then I also want a larger text. Let me remember how I did that. Font size width divided by 3. Yeah, we're almost there. Font size is also dependent on width. So width divided by 3. So that next time when we resize the window, the text will also get smaller, instead of just like shooting out from the canvas elsewhere. And then I wanted also a color of fill of the text. It's called fill. Now I have the color. And finally, I also want, there's like all of these tricks that we learned at Gapminder while building these bubble charts and so on. Do you see the problem with text right now? When I scroll the time slider, it jumps left and right. It takes too much of your attention. Now everything that you see is the jumping text. How to not allow the text jump? Do you know? It is centered. It has to do with typography. Have you heard of sans serif fonts? Have you heard of monospace fonts? So monospace means that every digit here takes exactly the same space on the screen, yeah? So that's monospace. Now the text stopped jumping. Now you can actually see the data and how the data changes. So we have covered the entire building of the bubble chart. And one last thing that I wanted to show you is what if we now want to show it to the world? Well, this is already public on the internet. Yeah, if I press share and I check that it's public, can view, I can give it some kind of nice name, bubble chart, let's say. That's good. And then I save that. And if I say open some other browser, which is not logged in here, and I go to the same link, you see it's already there on the internet. Yeah, but let's say we only want our chart and nothing else. If I press here, this button, in programming we call it kebab button, because it's like 3 dots vertical. You see embed, but it's not available here. This is because it wants you to name the cell. And once you name the cell, then it becomes available. Embed, then you can press that. It gives you a little window here, and this is the result of your embedding into your website. Now I have chart, but I also can select my year, and now I can also have the slider together with me. Yeah. Then I press copy here, and then if I go, I wanted to show you as it can be any website, but I'm teaching at a university, so I have this Canvas. Have you heard of Canvas? It's like for teaching students. And here I press edit on a page in Canvas, and here I can type like assignment or announcement to my students or anything else. And here is like a little button that lets me switch to code. And if I press that, then I can paste my thing that I just have copied from observable. And if I exit that mode, I have it right here. And I can type here. Can I type here? I was convinced that I can type in this thing. Yeah, here. Just found the cursor. Hello students. Whatever. And then if I press save, here is my Canvas page, and here is the hello students. And here we have the chart. And it's all done. So now it's interactive on the website. Yeah. So I'm super happy that it worked actually, because the live coding is always like, oh, what if I make a mistake, and what if I cannot recover? So for that purpose, I made these slides for you that just do everything like what I did now, but they show you the steps. And you have these slides; they will be shared with you by the organizers. Here's the final product, and here is fully interactive on your website. So it's the same, everything is the same in the slides. And now, this took us like 30 minutes, and now the technologies are so advanced that we can do it just live in front of the audience of 100 people. But we've been doing it for some time at Gapminder, and if you do this for maybe 5 more years, or 10 more years, then you end up with something like this. And this is called Boendebarometern. This is what we do together with Uppsala University, like a little project with them. You may recognize the user interface. This is because we first did it with Marcel. And then we were too slow to developing it. We found some problems in the data model, and we took a couple of years to fix them. And Marcel was like, damn, these guys couldn't do shit. So he asked another developer to build him Hydinganalysen. And the other developer built his tool, and by the time that the other developer built his tool, we also built our tool, which you see right here. But our tool, and then we end up with 2 copies of the same thing, except his was better. Because his could do like 6,000 bubbles very smoothly, and mine could only do like 200 bubbles very smoothly. And then we started like researching why is it happening, what's wrong. But it's nice that Marcel and his developer took like a complete copy of this, like a rip-off, and made it themselves. Because then we looked at how his thing is done, and then we did the rip-off of his thing. And now we use the same technology as he and his developer is using in Hydinganalysen, and now our tool can also do 6,000 bubbles, no problem. So this is a healthy competition for you. But it shows all of Sweden. And here, if I start changing my variables here, I can change like personbilar. Antal personbilar. I find that exciting. Like, okay, how many cars do people have in different parts of Sweden? And here, instead of inkomst, people in Uppsala, they like to have inkomst on the y-axis. Weird people. I bring it back to x, and I make it logarithmic. But in y, I want sysselsättning. Sysselsatta invånare. Yes, andel sysselsatta invånare. And then I can zoom in like that. Now I have my sysselsättning. Look how weird it is. Like it goes up with the income, sysselsättning, but then it goes down, the percentage of people who are employed. And if we look at this graph, it only shows the communes. And this is not so epic, because you want to go deeper and deeper into the neighborhoods to see more nuance and more complexity of the data. So we have the buttons here where we can switch to RegSo. And then in the experimental version, we also have the DSO as well. But now we switch to RegSo. And I was expecting this to work, and this didn't. Nice. No, it didn't work. Okay, cool. Failure at the demonstration. No, because I'm in the Collada dataset. Collada dataset is only available for commune level. Yeah, but I have the full Collada dataset here as well. But if I go to Socioeconomie and I go to Sysselsättning from IBF, which compiled the dataset from Uppsala University, then I load my dataset for my subdivisions here, RegSo. Here I can also change the size of the bubbles, so they are a bit smaller. Now look, the pattern becomes more prominent. So in the RegSo that have more dispensable årsinkomst, they have less sysselsättning. And then I'm not a specialist to give you like any explanation of why certain things happen in the society. You have much more experience and knowledge to do this explanation when you see the data like this. So maybe when you have more money, you don't have to be employed that much. I don't know. But here is my point that averages are missing the story. But if you explode it to the tiny bubbles, then you get more nuance and complexity. Anyway, so if you've seen how I built this in front of you, and maybe it's a bit confusing and you have to do some coding, and I tried to simplify it as much as possible but still do it from scratch, yeah? That was the idea. And still I couldn't avoid writing some JavaScript there. So if you really want to avoid JavaScript and developing it yourself, then we have done it before, and we have done it for the last 10 years, and now it shows 6,000 bubbles, and it's working, and it's flexible data model, so I can have DSO, I can have different filters, I can have, this is one of the recent additions that I have. So if I have communes here, and I change it like that, my communes, I can explode Stockholm to RegSo, and now my bubble for Stockholm is replaced with Sollentuna and Kista and others. And if on the map it also exploded to subdivisions. So all of these cool tricks that we can do because the data model is now flexible, because we took time. We lost Marcel, but we took time to rebuild it.
Is this open with the last thing you did with RegSo?
It's fully open.
Oh.
This is also like the point that good that you reminded. It's open source. The data is public. The tool is public. The source code is public. So if you have developers yourself, I don't recommend that much suffering, but you can clone it and you can do the development yourself. But it's possible. So there's no risk that it will be acquired by some large company and then they will kill the software. Yeah, but sometimes that happens. So Visabi is the software that animates numbers over time, bringing them to life, so that the truth can win over buzzwords. This is what we do. We add play button to your data, and we also add, we can do custom graphs like this. Here are some racing bar ranks, and here are migration between provinces in South Africa. So we can also do custom graphs for you. And I would like to conclude with this quote attributed to William Blake: "If the truth can be told so as to be understood, it will be believed." Yes? This lecture and other lectures that I teach at the university, I put them here on YouTube in ChartMe videos. So if you want to go again through what we did today, you can go there. This is the previous version of that, and I've recorded my screen now and my face so that I also can put that there. But now if you want to ask questions, I stop the camera so that your voice will not be there. Okay? Thank you so much.